Okay, today we're going to talk about how we solve rational equations. And the idea here is very similar to what we were doing last time when we got to complex fractions, where we were clearing the fractions. So how many people want to get rid of fractions? Would you prefer to have an equation that had no fractions? Okay, so we can actually magically, it's not really that magical, but it's math magic. We can use our math magic to clear the fraction by using what we call the lowest common denominator, that's LCD. And so what is the LCD? Here I have a denominator of 4, 4, and 6. So let's first determine the LCD. Anybody know what it is? Okay, 4 times 6 would actually be, you could use that. That would be 24, but it's actually too big. And so let me describe how you might find the LCD between 4 and 6. If we have 4 and 6, we have 2 times 2, and 6 is 2 times 3. Since they have a shared 2 in common, I only have to use that 2 once. And then I have an extra 2 and an extra 3. So the LCD here is going to be the shared 2 times the extra 2 times the extra 3, and that gives us 12. And you could use 24, it's just that you're making it bigger than it needs to be, and then you'll have to whittle it back down in the end. Yes? Yes, so each time you could always factor the denominators if you wanted to help you get the LCD. So now what we're going to do is we're going to actually multiply both sides, and that's everything. Each term gets multiplied by 12. Okay, 12, 12, 12. Why do we do that? Well, I can do whatever I want to an equation as long as I do the same thing to both sides, right? So I'm totally within the law, the legal limits here to multiply both sides by 12, yeah? I'm not changing the value, in other words. The reason why we do this is because if you have 12x divided by 4 equals 12 divided by 4 plus 12x divided by 6, you could reduce that. I could have also cross-canceled, right? 4 goes into 12 how many times? So that's 3x. That's the same thing. 12 divided by 4 is 3. 4 goes into 12 how many times? Oh yeah, you just said it, 3. So I could have cross-canceled here, 4 into 12, 3. It just gets a little messy there. 6 goes into 12 how many times? 2. So that means that 12x over 6 reduces down to 2x. So that's the cross-cancel method, but it can get a little bit confusing. That's why I just wrote this extra step where I'm multiplying, and then essentially from multiplying, I'm reducing, right? So now that's a much friendlier equation to solve, now that you don't have any fractions there. So what would you do to solve for x now? So I want to get I have 3x over here and I have 2x over here. How can I get all the x's onto one side? So if I subtract 2x, I get 3x minus 2x is how many x's? X equals 3. Now, the important thing is that once you get your answer, and you might put it in set notation, 3, and remember I'm practicing my braces. That one looks... One of them always turns out really nice. The other one turns out weird. That's okay. The other thing we want to do is make sure that our answer is correct by checking. And this will help you if you have any mistakes along the way. So what we do to check is we're going to take the original problem and we're going to put that 3 back in for x. So I have 3/4 is equal to, well, I'm not sure if it is yet, 1/4 plus 3 over 6. Okay, so again, if I want to add fractions, I need a common denominator. So I could clear fractions right here, or I could just use a common denominator to add. We know the common denominator between 4 and 6 is 12. So to get this one to be 12, I'm going to multiply by 3 over 3. To get this one to be 12, I'm going to multiply by 2 over 2. And I have 3/4 might be equal to 3/12 plus 6/12. And 3/12 plus 6/12 is 9/12. And if you know anything about reducing fractions, 9/12 should reduce down to 3/4, because what's the biggest number that goes into 9 and 12? 3. So if you reduce by dividing the numerator and dividing the denominator by 3, you end up getting 3/4. And the only reason why I didn't carry my work down vertically here is because I was running out of space. So it looks like it checks out, and so that way I can feel pretty good about that answer. Now that was actually not even a rational equation necessarily, because it was really a linear equation because there was no variables in the denominator. Now we're going to get to a problem where we actually have variables in the denominator. So what could we do to clear fractions? Could we use the same concept there? What's the LCD of the denominator here? 3 and x, okay? And what's the denominator on the 1? It's actually 1, right? So if I multiply both sides by 3x, I'm going to multiply this term by 3x, this term by 3x, and this term by 3x. Okay, so I end up getting, what happens to the 3x and the 3x? Do I need to really multiply that out and then divide it? The 3x and the 3x cancel, leaving 5, plus the x and the x cancel here. So we have 3 times 3 is 9, equals, does anything cancel with the 3x? So what's left on that side? 3x. Now, how could I simplify? How could I solve for x? Sorry. Right, because, well, I would want to combine these, so I should have 14 equals 3x, and I could divide both sides by 3, and I get x equals 14/3, which is a little unfortunate that we get a fraction. I wish it had been a rational number because it's a little bit easier to check, but we can still check it, okay? So I'm going to actually, since I have more space over here, I'll put my check here. And to check it, I'm going to plug it in. I am going to get some complex fractions, but that's okay. We know how to deal with those. So we have 5 over 3 times 14/3. That looks weird. I agree with you, but it's just a complex fraction, right? Fraction within a fraction. Plus 3 over 14/3. Is that equal to 1? I put the question mark over the equal sign because I'm not sure. What if I had made a mistake solving? Then I might have gotten the wrong answer. So I don't know if it will equal. That's what I'm trying to find out. So what happens here? Can anything simplify within that complex fraction, that first one? The 3's do cancel. So we end up getting 5/14 plus, how can I deal with this? This is 3 divided by this fraction. Could I go 3 over 1 times the reciprocal? What's the reciprocal? 3 over 14. And again, is that equal to 1? Okay, so let's go 5 out of 14 plus, what's that when I multiply? 9 out of 14 equals 1. And that's 14 over 14 equals 1, and 1 equals 1. So that's the idea of how we would clear fractions with these two different kinds of problems. So we'll stop the video and you can try a few examples and then we'll try a few more together.